Hello, and here is a short little spiel about a different way to calculate or describe and calculate solution concentration, especially for very dilute solutions. Or in this case, in the first case of ordinary mass percent, you can use it for just about anything. When we're curious about how much of a certain mixture or composition is a particular component, we just take the mass in grams or kilograms or anything, divided by the total mass, which includes the mass of stuff in question, multiplied by 100%. That's why sometimes I call this the part per hundred concentration. 100%. Sometimes the percent confuses people. It's just multiplying by 100, moving the decimal 2 places to the right and sticking a percent on the end of it. For example, if I had 105-ish, 106 grams of Raisin Bran cereal, and I pulled the raisins out and weighed the raisins individually, or the sum total of the individual raisins, I found, and I seriously did this, sounds like a boring, nerdy thing to do, but I did it, 19.59 grams of raisins was contained within that 105.7 gram sample that I originally weighed out. Divide the two, you get 0.1847, take it times 100, stick a percent on the end, called 18.47% mass percent raisins in the Raisin Bran. Or you could say 18.47 part per hundred raisin by mass raisins in the mixture. Interesting, but very functional, very versatile, works with anything. Continuing that theme, let's do the same definition. Seems silly, but this is the same definition as above, except for this is not times 100, it's times 10 to the 6 or a million. And in that case, when I divide the mass of the component in question by the total mass of solution or total mass of mixture, then I get a decimal, but it's going to be very small. Part per million is used for very, very dilute solutions. So times a million at the end. I have a 2.5 grams sample. It's about 2.5 milliliters sample of water from the ground somewhere. Found to have 5.4 micrograms. A microgram is 10 to the negative 6 grams of zinc. What's the zinc ion concentration in part per million? Well, here's the definition. Part per million. 5.4 micrograms divided by 2.5 grams altogether. That's going to be a small number, so multiply it by a million, and it's something a little more convenient, 2.16 part per million. The zinc ion is not that dangerous, so I wouldn't worry about that concentration. I'd be too concerned about it as a general rule, but anyways, let's see, what was I going to say? Oh yeah, so many solutions and so much of chemistry and biology is done in water and aqueous. We can do simplification. If I have 1 gram of water, it's 1 milliliter of water, or 1,000 milliliters is 1,000 grams. So another name for a part per million is 1 milligram of solute stuff dissolved in about 1 liter of water. Here's an example. We're using the zinc ion we just saw a second ago. 1 milligram of zinc ion would be, or replace this with anything you like, 1 milligram of zinc ion in a liter of solution. Let's see, what's a milligram? Oh, it's 10 to the negative 3 grams. And what's a liter? Well, it's 1,000 milliliters, which is also 1,000 grams. So this is 1,000, this is 1/1000th. Times it by a million. Oh, yeah, right. 1/1000th divided by 1,000 gives a millionth. Take it times a million, and you get 1 part per million. And again, you can replace this with anything you'd like. Oh, let's see. So this right here, this milligram per liter, that's a very handy thing. Our book doesn't do a thorough explanation of part per million, part per billion. But if you go any further in chemistry, analytical chemistry, chemical engineering, it's pretty common. Part per million, part per billion, especially in environmental science. 11.25 part per million of lead nitrate. Oh my goodness, lead ions really bad. But what's 11.25 part per million mean? Well, if I go with the above simplification, that means 11.25 parts of lead nitrate per million parts of water. That's a million part. So Oh, let's see. I put 11.25 milligrams per liter. Let's massage that just a little bit. Change it from milligrams to grams in the numerator. Just move the decimal 3 places to the left. And I get 0.01125 grams of lead nitrate per liter of solution. And then remember the original question right up here said, what if I had a 100 gram or also 100 milliliter, very close to 100 milliliter, sample of this solution in a 100 milliliter sample? That would again be, what's another name for 100 milliliters? 0.1, move the decimal 3 places, 0.1000, 4 sig figs, liters. And I use, since I use this part per million designation, the description of the concentration as a conversion factor. So put the liters in the bottom. This liter cancels this liter, and that's a 1, and that's a 1. Oops, that's a 0.1. So 0.1 times that gives me 0.001125, and now I'm to the border where it might be just as good to use scientific notation. Let's do one more. Part per billion. Part per billion, this is exactly the same definition as I had above. The mass of the component in question by the mass of the solution altogether times a billion. So a billion is 10 to the 9th, or 1 with 9 zeros and back. Example, aqueous solution has 27.3 micrograms, again 10 to the negative 6 grams of mercury 2 chloride in a 500 milliliter volume. What's the part per billion concentration? I wrote out the equation here where the mercury chloride salt is able to dissolve slightly soluble in water. Well, the numbers I had were 27.3 micrograms. I might get that in grams, just like I have the denominator in grams. 500 milliliter solution is so watered down it's very close to just pure water, so 500 milliliters, 500 grams. Divide those two. Oh, that's 10 to the negative 6. Divided by 500, in other words, 0.0000273 grams divided by 500 times 10 times a billion gives me 54.6 part per billion. I have another question. Think about this. How would the definition for part per trillion and part per quadrillion look? They might be very similar to something we've already seen. Hey, thanks guys for watching.